Hello students, myself Nirupam Chatterjee representing Skoran Arena. Here we are going to discuss, we are trying to establish a book for the students who are aspiring NEET 2021. In this book we are trying to provide you a video solution of the total questions which we are accumulated in this book. So we are trying to represent this book in such a way that it would help you to go through a quick revision of the total syllabus for NEET 2021. Okay, so let us start with the first problem. And here the first chapter we are representing, it is basic concept of chemistry, and this total chapter we try to represent this total chapter in form of some questions which are asked in different exams, or if you go through this question paper definitely you will get a quick revision of this total chapter, that is basic concept of chemistry. So let us start with the first problem. The vapor density of a gas A, it is 3 times than that of gas B. If the molar mass of A is M, then what will be the molar mass of B? Some options are given. So basically the concept used to solve this problem, definitely it is the relation between vapor density and molar mass. We have this knowledge that vapor density of a gas or vapor, it is half of its molar mass. So I am writing vapor density it is equals to half into molar mass of a gas. So for simplicity, if we take the vapor density of two gases, that is A and B, if we take those as dA and dB, and the molar mass be Ma and Mb, so we can quickly solve this problem in very easy way. So given here the problem, it is given vapor density of a gas A, it is 3 times than that of gas B. So vapor density of A, if I will write vapor density of A, it is represented by dA, that will be equal to 3 times than the vapor density of gas B. Okay. Now, if we put this relation, vapor density is equal to half of into molar mass, so we can just replace these vapor densities by half into molar mass of A is equal to 3 into half molar mass of B. So, if we cancel out half from both sides, we have this relation Mb, as it is asked to find out the molar mass of B. So I am writing Mb, that will be equal to molar mass of A divided by 3. Okay, so it will be our relation molar mass of gas B, that is equals to molar mass of gas A divided by 3. So you can understand the answer, it will be option B, that is M by 3. The next question, it is also related to vapor density and molar mass of a gas. Now let's see the question. Gas mixture, hydrogen and carbon dioxide. Two gases, hydrogen and carbon dioxide, they are mixed in a cylinder, and that contains 88% of CO2 by mass. What will be the vapor density of the mixture? Now in this question, definitely a concept of calculation of molar mass of a mixture or vapor density of a mixture, it is given. So what is the idea? That is molar mass of a mixture, molar mass of a mixture, that is equals to, we have this relation molar mass of a gas or molar mass of a gas mixture, that will be equal to total mass of that total mixture divided by total number of moles. Okay. Now, by any means we have to find out the total mass of the mixture, and if we divide it by total number of moles present in the mixture, then it will give the molar mass of the mixture, or we may say this molar mass of the mixture, it is also called the average molar mass of the mixture. Okay, so we are going to this problem. It is given it contains 88% CO2. So if we take the total mixture be 100 gram, let the mixture be 100 gram. We have taken this mixture be 100 gram, therefore CO2 by problem it is given 88 gram, and 88 gram CO2 means we can write it is 2 moles. Definitely CO2 has molar mass 44 gram, so 1 mole means 44 gram, so 88 gram means it will be 2 moles. So the left amount, the remaining part, you will subtract 100 minus 88, it will be 12 gram. That means it will be equal to 6 moles, because hydrogen has molar mass 2. So you just find out, you just apply this concept in the above formula. Average molar mass that is equals to total mass, it is 100, total number of moles, it will be 2 plus 6 means 8. So we can simplify it, it will be 25 by 2, it will be equal to 12.5. Now it is asked to find out the vapor density of the mixture. So vapor density Vd of mixture, it will be half into molar mass, and hence you can get that answer 6.25. Okay, so we have this option here also, the option is B. Now I am moving to next question. Here also a problem, it is also a problem given on that same concept. The same concept, that is here the mixture composed of SO2, O3 and O2 in the molar ratio it is given. And here also we have to find out the average molar mass. So I am directly using the formula. If I would take the SO2 and O2, the ratio of the moles of the 3 gases, it is given 1:3:2:3. Okay, so I am taking, it is given by mole ratio. So I am directly applying the previous concept, that is average molar mass. That will be equal to, suppose if you take x mole SO2, so x mole SO2 it will have the mass 64x. If you take 2x mole O3, it will have the mass 96x. If you take 3x moles O2, so it will also have the mass 96x, and divided by total number of moles x plus 2x plus 3x. Okay, so what the concept I am using, I am taking a common ratio of this common factor of this ratio, that is x. So SO2 present, it will be x mole, O3 present 2x mole, O2 present 3x mole. So definitely we can convert their moles into mass, because SO2 has molar mass 64, O3 98, 48, and O2 it will have 32. So we can solve this. It will be equal to 12, 12 and 4, it will be 16. It will be 256 divided by 3 to 5, it will be 6. So cancelling, we can get the relation 128 by 3. So we have this option also. Here also option, it will be B. So I am moving to this question. Vapor density of a mixture of NO2 and N2O4, it is given 38.3. And I have to find out in 100 gram mixture how much moles of NO2 is present. So the mixture given, that is equals to 100 gram. It is supplied 100 gram of mixture, it is given. So NO2, let we take the NO2 present in that case, it will be x gram, and x gram NO2 means it will be x by 46 moles. So the rest portion, the rest amount, it is N2O4, that will be 100 minus x gram. So our amount, if we convert it into moles, it will be divided by 92 moles, since N2O4 has molar mass, it will be 92. So average molar mass of the mixture, average molar mass, that will be equal to total mass. So I am telling from the beginning that total average molar mass, it will be equal to total mass by total number of moles. It will be equal to total mass by total number of moles. So total mass 100 gram, total moles x by 46, 100 minus x by 92. So if we simplify it, so you can realize it, the LCM it will be 92. The LCM will be 92. If we move it to in the numerator, it will be 9200. It will be x plus 100. Now by problem, this value, it is will be equal to 2 into this value, that means 2 into vapor density. So I am dealing with this. Therefore by problem 9200 by x plus 100, that gives 38.3 multiplied by 2, because it is given the vapor density, multiplied by it we will get the molar mass. So x plus 100, that will be equal to 4600 by 38.3. Okay, just cancelling this. So x is equal to we have 4600, it will be 4600 minus 100, and hence 4600 minus 3830 divided by 38.3. So if you just calculate this value, it is 0 followed by 7, it will be 770 by 38.3. By 38.3. So think it will be almost, if you multiply this by 2, you will have this value 76.6. So you can approximate it. To it will be approximately 20. Just 38.3. These things you have to apply in your exam. examination paper. If you multiply it by 2, it will be approximately close to 77. So you can cancel it by 2, and for 10 it will be 20. So moles of NO2. Moles of NO2. NO2, that will be equal to 20 grams. So moles, it will be 20 by 46, and definitely it will be 10 by 23. You can find it. This value will be 0.4 approximately, 0.437 approximately. So our answer, it will be 0.437, and which is given in our option. It will be 0.437. Okay, it is option A. Okay. Now I am moving to the next question. Here also a question given in terms of vapor density of the mixture of air, which is in which volume percentage of nitrogen gas it is 80 and volume percentage of oxygen gas is 20. Now here volume percentage is given, and you have to find out the vapor density or maybe the molar mass. So volume percentage, we have identified what will be the concept behind to solve this problem. So we have ideal gas equation. Ideal gas equation. Now when it is given that air, so air means it will be an air in some place. So when we consider some sample of air, it will have constant temperature and it will have pressure constant. So if we take air be the ideal gas, so we can use PV is equal to nRT. Now since pressure is constant, now since this value pressure is constant, since pressure is constant and temperature is constant, R is also constant, so volume proportional to number of moles. Volume will be proportional to number of moles. So when you are given the volume percentage, you can consider those values as mole percentage. The concept here, we use volume percentage, volume, it will be proportional to percentage moles. So if it is given volume percentage 80 and volume percentage 20, you can consider them as mole percentage. So I am directly using average molar mass. Average molar mass, that is equals to, so total moles, the volume percentage, I am taking total moles, it will be 100 moles. So if we take 100 moles, then what will be its total mass? We have 80 moles nitrogen. 80 moles nitrogen. So 80 moles nitrogen, it will have the mass 80 into 28. 1 mole nitrogen means 28 gram, 80 moles means 80 into 28 plus 20 moles oxygen means 20 into 32 divided by total number of moles 80 plus 20, it is 100. So you can solve it. It will be 8 into 8, 64, and 8 to the 16 plus, it will be 460 divided by 100. Now you can solve this question. You can solve definitely it is equals to 0, 8, it will be 8 2 by 100, that is 28.8. Now the question asked, what will be the vapor density? The molar mass we find, therefore definitely the vapor density of air, vapor density half into molar mass, 28 by, so it is 14.4. It is 14.4. So our option, definitely we have this option, it is 14.4. It is 14.4, option C. So the basic concept we deal with these problems. That is, when we try to find out the average molar mass, we are only concerned about how to find out the total mass of the mixture and total number of moles. And if it is given in volume percentage, if temperature and pressure is kept constant, here you can say that definitely temperature, pressure constant, it is not given in this problem. But when you are dealing with air, definitely that sample of air, it belongs to some place. When it belongs to some place, it will have constant temperature and constant pressure at that place. When temperature and pressure constant, you can consider volume percentage, it will be related to percentage of moles. Okay. So we have the next problem. This problem, it deals with the molar mass of any substance that will occupy a volume 22.4 liter at NTP, or we say molar volume, that is 22.4 liter at NTP. That concept we have to use to solve this problem. So 24 gram of a solid element, it is burnt in presence of 44.8 liters of O2. So 44.8 liters of O2, that means 44.8 liters of O2 means 2 moles O2. That means 1 mole means 32 gram, 2 moles means it will be 64 gram of O2. That is required to complete combustion of 24 gram of solid element. Then we have to find out some informations related to this problem. So let us try to solve first. We have to find out mass of the gaseous product. What will be the mass of the gaseous product? Molar mass of the gaseous product, vapor density of the gaseous oxide. These things we have to calculate. If it will match from this problem, then okay. If don't match, then we will give none of these will be the answer. Okay, so let us try to solve this problem. Gaseous product formed. I am writing directly. Gaseous product formed, that is equals to. So this gaseous product, it is formed by the combination of 24 gram solid element plus it is 44.8 liters of O2. So you can write 24 gram solid element plus required amount of O2 in terms of mass, that will be 64, because 22.4 liter means it will be for oxygen 32 gram. So 44.8 liter means 64. So we have 88. So gaseous product formed, it will be 88 gram. Gaseous product formed, it will be 88 gram, but it is given 44 gram, which is wrong. So option A, it is wrong option. Now the next case, this gaseous oxide, it will occupy a volume of 44.8 liters. So gaseous oxide, for gaseous oxide at STP, I can write at STP, or you can say for NTP, it is given NTP, definitely 44.8 liters, 8 liters gaseous gaseous oxide, that is equals to 88 gram, and therefore 22.4 liters gaseous oxide, it will have a mass 44 grams. So we have this idea. If molar mass, it corresponds to 22.4 liter. So 22.4 liter, it will correspond to 44 gram. That means molar mass. So molar mass of gaseous oxide, molar mass of gaseous oxide, that is 44. Now molar mass of gaseous oxide, it is given 88, which is also wrong. Now the left portion, what will be the vapor density? So simple, vapor density vapor density of that gaseous oxide, that will be half into molar mass, that is 22. So I think this is given in the option, that is vapor density of the gaseous oxide is 22. So it goes to, for question number 5 we go to, it will be option C is the correct option. Okay, option C is the correct option. Next I move to the next question. Here also a gas mixture is given. Gas mixture, it is methane, gas mixture, it is ethane. And the condition given, it is equimolar proportions. Equimolar amounts are given. So if we take CH4 by X mole, so C2H4 is also present by X moles. Okay, so I am writing average molar mass, again average molar mass, that is equals to, think, I am taking that both CH4 and C2H4 present by X moles. So X mole methane, that means 16 into X grams. So 1 mole methane means 16 gram, methane has the molar mass 16. So X mole methane means 16 X gram plus it is C2H4 ethylene. So ethylene, it has the molar mass 28. So it will be 28x. So divided by, it is the total mass, total moles, it will be x plus x. So you can solve this question. It is definitely 22. So molar mass of the mixture, it is 22. Now it is asked what will be the mass of 2.24 liter of the gas mixture at STP. So at STP I can write, at STP 22.4 liter gas mixture, it will weigh, it will have the mass that is equals to 22 gram. So you can find out 2.24 liters, that will be equal to 2.2 grams. So the answer, it will be 2.2 grams. The answer, it will be 2.2 grams. So again, it is a question where we have to find out the molar mass of the mixture, and for calculation of molar mass, total mass by total number of moles. This concept we are again utilizing in this problem. Okay. So let us deal with the next problem. It is given 600 milliliter of a mixture of O3 and O2 is given. That will have a mass 1 gram at NTP, it is provided. What will be the volume of ozone present in the mixture? That means 600 milliliter, it contains how much milliliter of ozone, that we have to find out. So let us take ozone present in that mixture, that is X milliliter. All the conditions they are given at NTP. Provided conditions given, it is NTP. So 6x milliliter ozone means it will be x by 22400 into 48 grams. So think how to find out, how I am dealing with this. So 22.4 liter, that means 22400 milliliter ozone, that will correspond to its molar mass, that is 48 gram. So 1 milliliter, it means it will be 48 by 22400. So x milliliter means this. Similarly, O2 is equal to, that will be equal to 600 minus x milliliter. So that will also have the mass 600 minus x by 22400 into 32 grams. Okay, so these volumes, x milliliter, 600 minus x milliliter, they are converted into grams. So that amount will weigh, that amount will be equal to 1 grams. So by problem I can write 48x by 22400, 32 into 600 minus x 22400, that is equals to 1 by problem. It is given in the problem. So you can solve it. 48x plus, it is 12, 19 minus 32x, it is equals to 22400. So let us 48, 32, so it will be 16x, that will be equal to 224, just subtract it, 0, 0, 2, 3, and definitely x is equal to, it will be 200 milliliter. So O2, O3 present, that is 200 milliliter. Okay, so we have this option, it is 200 milliliter, option B. Okay, so we are dealing with our next problem, that is, so a compound A, a compound A, it is undergoing nth order dissociation with degree of dissociation alpha, where dTH and D observed, they are given the theoretical and observed vapor densities. So I have to find out which of the following relation is correct. So let us take a species AN. I am taking a species, that is AN. AN, it is a species. It will undergo nth order dissociation, means it will break up to produce n number of fragments. If we take AN, it will break up to produce n number of A. That means it will undergo nth order dissociation. The word nth order dissociation means if we take a component, if we take a molecule, it will undergo nth order fragmentation during this process. Now I am taking 1 mole, say initially 1 mole of the component is taken. Say I have 1 mole of the component, and when there is no breakage, so definitely the component A produced, it will be 0. Now if it will break up to produce, it will have a degree of dissociation alpha. What is meant by alpha? If we take 1 mole, then it will break up to produce alpha mole of that component, it will degrade, and 1 minus alpha mole, it will remain intact. Okay, so if alpha is the degree of dissociation, so alpha mole of AN, it will break up to produce n alpha number of moles of A. Okay, so by definition, degree of dissociation alpha, it means if we take 1 mole of A, it will break up to produce n moles of some quantities. So definitely average molar mass, I am writing directly average molar mass after fragmentation. That means it is after fragmentation, it is definitely a mixture. So total mass means if we take 1 mole corresponding mass, it will be the molar mass. So I am writing, it will be the actual molar mass, that is representing by theoretical. It is theoretical molar mass divided by total number of moles. 1 minus alpha plus n alpha, and by problem this average molar mass, that will be this average molar mass, we can write it will be the actual molar mass, or we can write the observed molar mass, M observed, that will be equal to M theoretical by, it will be 1 plus n minus 1 into alpha. Okay. Now, these are observed molar mass, these are theoretical molar mass, and we have this relation. If we convert these molar mass into vapor densities, if we try to convert these molar mass into vapor densities, then definitely it will be twice into vapor density, that is D observed. It will be equal to 2 into D theoretical by 1 plus n minus 1 into alpha. Okay, now cancelling d from both sides, we can get this relation 1 plus n minus 1 into alpha, that is equals to d theoretical by d observed. So just move this one in the another side. So we have n minus 1 into alpha, it is equals to dth d observed by, it will be d observed. So finally we have alpha is equal to dth d theoretical d observed by n minus 1 into d observed. So it will be the relation. It will be the relation. So definitely you can find out this relation in the given problem. So try to find out. So we have definitely alpha is equal to dth minus d observed, dth minus d observed by d observed into n minus 1. Definitely we go for this option. Definitely it will be option A. The important factor which you have to memorize related to this problem, here what does this n represents? N, it will represent, if we take 1 mole, it will produce how much moles of products. Always deal with this term. N means, here this term N means, N it will represent, if we take 1 mole, how much moles of product is formed. This N will have this significance. Okay, now I am quickly shifting to the next problem, which is also related to this idea. Here also this question have some reactions which are given in the column 1 or column A, and their corresponding alpha values, degree of dissociation, which are asked in column B. We have to match, which matching is correct, we have to find out from this list. Here D, capital D, it deals with the actual vapor density, that means theoretical vapor density, where small d, it represents the observed vapor density. Okay, so I have to use the formula directly here. Alpha is equal to actual vapor density, that is theoretical vapor density, capital D, minus it will be observed vapor density divided by, it will be n minus 1 into, it will be the observed vapor density small d. It is the actual relation. And here this n, again I am telling this value n, it deals with the number of moles of product formed from 1 mole of the reactant. Number of moles products formed from 1 mole of any reactant. 1 mole of reactant. So in this concept we have to apply to solve this problem. So here we have 1 mole A, it will produce n by 2 mole B and n by 2 moles C. So directly apply for this reaction. So for first reaction, it is A giving n by 2 mole B and n by 3 mole C. So I will directly use 1 mole A, it will produce total number of products, total moles of products. total moles of products. How much? Total moles of products, it will be n by 2 plus n by 3. That will be equals to 5n by 6. So 1 mole A, it will produce total number of products 5n by 6. 5n by 6. Now you apply this in the above formula. Therefore, alpha is equal to, we have alpha is equal to d minus small d divided by 5n by 6 minus 1 into d. So simplify it, you will get the correct answer. D and followed by 5n minus 6 into small d. Okay. So in case of problem 1, so try to find out which one is given. 1, it corresponds to definitely 5n minus 6 into d. So it will have this relation. It will be the it is A1 is related to Q. Now by the similar way I can try to find out the other situations. The next situation, it is given reaction 2. Reaction 2, it is given think A, it will produce n by 3, B and 2n by 3 C. I will write in this case directly. I will try to write it down now. So how many total number of products are formed? Total number of products are formed. So you can write alpha is equal to, here alpha is equal to, for 2, alpha is equal to d minus small d divided by total number of products means n by 3 plus 2n by 3 minus 1 into small d. So just simplify it, you will get this relation d minus d divided by, it will be n minus 1 into d. Okay, so column 2, column A, the 2, it deals with P. It deals with P. For the same way, you can also find out in case of 3. In case of 3, I can also find out, let's for 3, alpha is equal to again d minus d divided by, it will be n by 2 plus n by 4 minus 1 into small d. Simplify it, it will be 4 into d minus d, 4 into d minus d by 3n minus 4 into d. And by the same way, definitely, so option A3, it relates with S. And definitely by the same way, you can find out also n by 2 plus half, and the relation it goes to R. So we have the correct option. We have this correct option. 1, it relates with 1, it relates to Q. 1, it relates to Q. Or 2, it relates to P. 3, it relates to S. And 4, so it will be option B, the correct option B. So basically, to solve this problem, you have this concept that alpha is equal to, it will be observed vapor density and in terms of actual vapor densities. If you memorize this formula and if you consider this idea that N here represents, if we take 1 mole, how many fragments are produced, that is represented by N, then it will be easy to solve this problem.